So today what we're going to be doing is graphing square root and cube root functions. And we know we've been working with square roots and cube roots so far in this unit, and we've looked at other roots, but we're just going to focus on square root and cube roots when it comes to graphing. Now, the square root function, if you look at the picture of it, it's a halfway sideways parabola, because a full sideways parabola would look like that. So this is just half of it. Okay? And it goes up into the right. Our domain, though, what we need to worry about with the domain is that we can't have the square root of a negative number. So our domain, there's two ways to think about it. One way is x minus h has to be greater than or equal to 0. Now, you can simplify this or generalize this and just say, oh, in this form, our domain is going to be x is greater than or equal to h, or h comma positive infinity. Those all mean the same thing. All three of those all three of those statements are true. X minus h being greater than or equal to 0. If I add h to both sides, that gives me x is greater than or equal to h. So I want everything that is h equal to h or bigger. Well, here I'm saying that h is included in my domain, and we go all the way to positive infinity. So generally, we are going to see a lot of this, but I really want you to understand that it comes from this right here, that the square root, the stuff inside the square root, can't be negative, so it has to be greater than or equal to 0. Now, the range, our range is going to have to do with that k value. That's our vertical shift. A, h, and k, again, are doing the same things they've done all year. So our range is going to be k comma infinity or negative infinity comma k, depending if your a is positive or negative. To plot, we're just going to plot our hk, our starting point, and then we're going to draw the half parabola the correct direction according to the a value. So if I go back up to the picture here, what's drawn here is the square root of x. So this is a positive a value, and if a was negative, it would go underneath. Negative a value. So notice when you put the two halves together, you get a full sideways parabola, and when we take the square root of something when we're solving, we need plus or minus, and this is the reason for that. Now, cube root functions. The cube root function looks a little bit weirder because you can take the cube root of a negative number. You may look at this part right here and say, oh, that's the same thing as a square root. Yes, but you also have this part right here. Okay? Because you can take the cube root of a negative number, we don't have any restrictions on our domain. Everything looks the same except this right here, that index of a 3 tells you it is a cube root. Now your domain is negative infinity comma infinity, and your range is also negative infinity comma infinity. To graph, the graph is a sideways snake here. To graph, though, we're going to plot that h comma k. That's called an inflection point. And then we're going to draw this sideways snake according to the a value. So here, again, this is a positive a value. If this were a negative a value, it would look like this. A reflection over the x-axis. We know all about that. So negative a value. Let's fix that up here, a value. So yeah, we don't really have any other points that we're going to plot, so you really need to understand the shape of this. If you just have one point plotted and you just draw a random line, you're not going to get credit for that. You need to understand that it looks like this weird sideways snake or this weird stretched out S. Alright, so let's graph a few. We're going to graph this y equals -2 square root of x, so state the domain and range, and compare the graph with the graph of y equals the square root of x. So comparison is RST. There is a reflection over the x-axis because a is negative. There is a vertical stretch because the numeral in front of the square root is 2, which is bigger than 1, but there is no translation. Okay, there's no translation, so there's no h or k value. So I'm going to start here at 0, 0, and because it's the negative a value, we know it goes down this way. We don't need to do anything else. I'm not going to get very picky on if you do something, if you do something like this instead, that's okay. If you do something like that, that's getting a little not okay, but it's still acceptable. Just don't do that. That's clearly not a square root function, that's a line. Just a nice little sideways parabola. Now our domain and range is dependent on that point there. Our x values are going to infinity, so our domain is 0, infinity. Our range, the y values are going down, so it's going to be -infinity, 0. So it's a lot easier to graph these than it is to graph some of the other types of functions we've talked about. The next page we have a cube root graph. Y equals 1/2 times the cube root of x, state the domain and range, and compare with the graph of y equals the cube root of x. Well, because it's the cube root of x, -infinity, infinity for domain and range. For a cube root, that will always be the case. Comparison. There is no reflection. Shrink or stretch, that's a 1/2 in front, so a vertical shrink. And translation, there is no translation here. So we're going to plot that 0, 0 point, and then we're going to draw our sideways snake. So it's going to start this way, come up and touch the point, and go that way. So that is 1/2 times the cube root of x. Now you say, well, how is this look any different than what we started with? I'll be honest, it doesn't look all that different. The goal for this is to understand what these functions look like and where do they start. So example 3, we have y equals 2 times x plus 4 to the 1/2 power plus 3. State our domain and range. Now notice we don't have to compare this one. 1/2 power, remember the 1/2 power is the same thing as the square root. So now we could look at this as 2 times the square root of x plus 4 plus 3. Okay. So now our domain, okay, we take this, is that it greater than or equal to greater than or equal to 0, minus 4 for both sides, x is greater than or equal to -4. So that means our domain is -4, infinity. So our starting point is going to be -4, +3. 1, 2, 3, 4, comma, positive 3, 1, 2, 3. All right, then since our a value is positive, we're going to go up. So it's up, going up towards positive infinity. So then our range is going to be positive 3, comma, infinity. So I think it's sometimes a little bit easier with numbers there because students think, oh, 0, 0, that can't be right. I must be doing something wrong. Nope, you're not doing anything wrong. It really is that intuitive. Right, then example 4, cube root. So automatically that makes our domain negative infinity, comma, infinity, negative infinity, comma, infinity. Now our starting point is going to be positive 1, the opposite of what you see, positive 1, comma, positive 2. So 1 over 2 up. It is a negative a value, so that means the right side is going to go down, and the left side is going to come up. So we get our sideways snake. All right, then on the next page, I want to go back and focus just on the domain of these radical functions, not the range, just the domain. So we're going to find the domain of these functions. Remember, like I said earlier, we can't have the square root of a negative number, and we can't have 0 in the denominator. Well, we're not dealing with fractions right now, so that part's going to go on hold, but that green part, we can't do the square root of a negative number. So kind of like we did with the other example, this is a square root, so we have to take the inside, set it greater than or equal to 0, minus 4 from both sides. X is greater than or equal to negative 4. Now that is technically a correct domain statement. That's called inequality notation, but we've always done interval notation and say negative infinity, comma, 4, because this inequality notation says x is greater than or equal to negative 4, so anything bigger than negative 4. In this interval notation, that's saying from negative 4 all the way to positive infinity. Well, negative 3, negative 2, negative 1, those are all bigger than negative 4. So they mean the same thing. Ooh, letter B looks different because we have a 5 in front of the x. You're not just going to say, oh, this is going to be, 9, comma, infinity, because it's the opposite of what we see. Notice how there was no number in front of the x there. So that's why I really want you to understand that we get this by taking the stuff inside the square root and setting it greater than or equal to 0. Add 9 to both sides, so we get 5x is greater than or equal to positive 9, and then divide by 5. X is greater than or equal to 9 over 5, which in interval notation will be 9 over 5, comma, infinity. And we have the bracket because you are allowed to take the square root of 0. That is 0. Right, now, lastly, letter C, oh, it's a cube root. So our domain is negative infinity, comma, infinity, done. Nothing more to do. So square roots are the ones that we really have to worry about when we're thinking of domain and range. Now, the last one, create a square root function where there is a vertical shrink, reflection across the x-axis, and a starting point in quadrant 3. Identify the domain and range of your function. Well, quadrant 3, 1, 2, 3, 4. So I want my starting point to be here somewhere. So let's just say our starting point. -5 comma -7. So we're going to have y equals, well, we want a reflection and a vertical shrink. So a reflection means it's going to be negative in front. A vertical shrink means the number needs to be smaller than 1, so maybe like 1/3, times the square root of x. Since I want to be in quadrant 3 and I have a -5 as my starting point, it's going to be x plus 5 and then -7 on the outside. Okay. So if that's where our point is, and we know it has a reflection across the x-axis, or a value is negative, we know it's going to look something like that. Again, it's not super accurate, but it gives us an idea of where the starting point is, and are the y values going up or down. Because the y values are going down, we know negative infinity is going to be in our range. So our domain is going to be -5 comma positive infinity, and our range is going to be negative infinity comma -7. So that's it for graphing square root and cube root functions. Really not that bad. You just have to be okay with, there's only one point we're going to plot. You have to know what shape the function will take based on square root, cube root, and positive or negative a values. So thanks for watching. Make sure to like the video and subscribe.